Day 41, Honors Physics, Energy, Problem 22. Here we have a tennis ball of 58 grams. You will want to convert that to kilograms. Here I'm outlining the process. I'm not doing it for you. Draw your picture. You have a ball that's going from A, ground level, up to B, maximum height, back down to C, same level as A. So it's giving you some information and asking you how much energy was dissipated or lost or turned into heat as the ball travels through the air. So what you will want to do is calculate the kinetic energy at point A. That's my first step over here on the right. So that's your first step. Calculate the kinetic energy at A, because you know the mass of the ball and the velocity of 20 meters per second. Calculate the, actually this is a mistake here, it should say calculate the kinetic energy at C. That should be a C right there, because there's no kinetic energy at B. It stops at the top. So calculate the kinetic energy at point C, and then subtract those two. The kinetic energy at C is less because it's less velocity, and that's the total energy lost or dissipated to heat during the flight. All right, once you have that number, say it's, I'm going to make up a number, say it's 12 joules of energy. Well, that means, it says in part B, you're losing half the energy on the way up and half on the way down. So if you've lost 12 joules of energy round trip, that means, say you lost 6 joules on the way up. So basically, that's what I'm doing for my first step in part B, taking my answer, dividing by 2 to get the amount of energy lost on the way up. And if I look back at my kinetic energy at point A and subtract that amount of energy, that gives me the amount of energy at point B. Or conversely, I could have taken my kinetic energy at point C and added that half of the dissipation to get back to point B. In other words, the energy at point B is halfway between the energy at A and C. But now it's all GPE. So then just set that last step. You take the energy at B and just plug it into the GPE formula, where you know the GPE at B, and you know the mass of the ball, and you know the gravitational constant of 10, or 9.8 if you want to use 9.8. The only thing you don't know is the height, and that will give you the height of the ball. So once again, using conservation of energy is much simpler than using kinematics equations to solve this problem.